So, hey everybody, seems like the time is about to start our today's Tech Talk, and I welcome everybody on today's Dynamic Talks number 72. Thanks a lot for finding time to attend our today's Tech Talk. My name is Vladislav Goman, and I'm an employee of Grid Dynamics. And today I would be leading one of the topics of our today's event. Also, besides, I do have my colleague from Belgrade, Vuk. Vuk, say hi.
Hi everyone, my name is Vuk Stefanovic. I will be holding the second topic after Vladislav. Nice to meet you all.
Yep, nice to meet you all. So, we're about to start, but I believe that most of people would connect in nearest 3 to 5 minutes, so we need to wait for them. And during this time, I encourage you to write to the chat to have some activity. And I'm really interested in which city are you located and where are you looking this tech talk from. So please don't be shy and mention in chat your country and your city. That would be that would be interesting to know uh, from which countries do we have our public. Oh, I see Belarus. Hey, yeah, Belarus is the country I am from, so nice to meet you. I believe we should have lots of locations because this Tech Talk is aimed for Europe, but I believe lots and lots of interested in the topic people would come from Ukraine, Russia, Belarus, and yeah, I believe we'll get lots of countries. Yeah, I see already lots from Russia, Krakow, Poland. That's the city I'm located at the moment. Lots of Russia. That's great. Yeah, we have already 40 attendees. Thanks a lot for finding time. Yep, and hello to whom have connected just now. Gdansk, what a beautiful city. I wish I could visit it once again in nearest future. Yep, so we'll wait for yet another 2 or 1 minute and we'll start. So for now, I'll start sharing my presentation screen. And so now I believe you should be able to see my presentation screen. Please copy that into the chat if you're not, because we're still waiting for guys to connect. Do you guys see the presentation screen? Cool, cool. I see lots of pluses. Yep, thanks, thanks. Thanks. Yep, and I believe we could start now with 3 minutes past already, and I believe many of you have already joined our today's Tech Talk. So to whom that joined recently, I'm reminding that you're connected to the Dynamic Talks by Grid Dynamics number 72, and today I, Vladislav Goman, would talk to you about Recoil JS library, and also my colleague Vuk would present his topic after mine. So let's begin. Yep. Let's get acquainted first. So yep, I'm Vladislav Goman and I'm working for Grid Dynamics as a software engineer. And my main specialty is front-end development. And I would say that React applications development is my current passion. So I'm trying to get up to speed with the current trends in the field and trying to learn the new technologies that in the area. And so not long ago, I found myself with a pretty interesting and promising performant library for state management, Recoil, and that would be our today's topic. So we would talk about Recoil JS, what is it, and well, shortly it could be called a state management library for React applications. And let's start. To begin with, I would like to talk to you about what this tech talk expects you to already know, so you would be able to understand what am I saying. And the first thing and the most basic is JavaScript. So the main programming language of this tech talk would be JavaScript. And if you know it, that would be already sufficient. And I believe you would be able to understand the most things of what am I saying. But it would be much more uh, beneficial if you would also know React library, because some of parts of examples, code examples would be written in React syntax, and so you would need to know React as well. And in case you would understand how it works, how do you um, make functional components, how do you give them state and stuff, that this tech talk is for you, so you would understand everything. And the last thing, but not least, in case you know Redux, the state management library, one of the most popular of them, that would be really cool because you would be able to compare Recoil with Redux, and you would be able to understand for yourself if Recoil is worth trying. So let's start. At the beginning, I would like to come through the plan for today's Tech Talk. And we'll start with the introduction to the topic. I will guide you through what Recoil is and why was it created and who created it. After that, we will move to the motivation. Why did Recoil developers thought of creating this library? Why did they share it with the world, with us? Then we'll move to the core concepts of Recoil. So we'll learn how to use it on a basic way, and so you would be able to learn it yourself in the futures if you would get interested with that. And then we'll move to the installation process, and we'll see how do we use Recoil on our local machines, on our local projects, and how do we install, what dependencies does it need and stuff. After that, I'll show you the big API reference of the library, and I'll show you it on an example application. So we'll see a kind of dummy example application that would get you up to speed with Recoil and why should it be used in any kind of projects. And after that, we'll have some time for wrapping up. And I believe if we'll have some time also, we'll have time for the Q&A section, where I believe you'll have some questions. So let's go. Yeah. Starting with what is Recoil? So Recoil is a state management solution, state management library for React applications. The interesting thing about it is that Recoil at the moment is in experimental state. So at now it is only in beta version, and the latest release is 0.4. But that's not something that should you worry about, because it is experimental and is in beta, because the developers of Recoil really want the library to be to consist of more features than it has now. And so they would just they want to wait until full-fledged release to make all these new features that are currently not in the build of library. But the existing features, the features that allow us to manage global state of React applications, are fully safe to use in production environment, and its creators are already using this library for their production projects, and not only, of course, their creators, because this library is kind of new, but it has already gained some kind of fame in developers community. Also, the cool thing about Recoil is that it has easy to use and intuitive API. So if you know React, that would not be a problem for you at all to learn Recoil, because the API is super simple to React, and it is really simple. So no lots of boilerplate code, and the learning curve is really flat. It's really easy. The thing I love most about Recoil is that async state queries are available out of the box, so you can change your state in an asynchronous way, and that is available right away. So you don't need any additional libraries, any additional layers of anything. You would just have it right away, and that's the thing I like most. Also, the beneficial for me, I suppose, that Recoil fully follows functional programming paradigm, and I believe that in ecosystem with React, I'm sorry, that is really suitable, because I don't say that object-oriented way of programming is any worse than functional programming, but I find functional programming in that particular case more suitable. And also a feature I would say of Recoil is it was developed by Facebook. Some of you may know that React, actually, the library React was also developed by Facebook, but the interesting story is that they were developed by different teams. And so Recoil wasn't developed by React core team. But the cool thing about is that the developers of Recoil, they worked in Facebook and developed some internal solutions for some internal platforms, and they faced limitations with the tools they had, so they couldn't implement things the way they wanted, and that was the reason why they thought of creating a new tool. And well, it appeared to be kind of interesting and promising, and so they decided to share it with the world and make it public and make it Recoil JS. And we'll learn it today. We'll talk about it. So let's go further. Now I would like to explain you. I would like to answer the question: what main issues, what basic issues does Recoil solve, and how and why do we need it? So it gives us flexible shared state, derived data and queries, and up-wide state observation. And let's talk in details about each feature. So flexible shared state is actually the main thing of any state management library, and it allows us to have pieces of state that are available anywhere from the React tree. And the cool thing about Recoil is that any kind of state that you create with Recoil is performant and optimized, and all kinds of optimizations are managed by the library itself. So you don't need to mess with caching or some kind of other optimizations. That is all managed for you, and that's what I found really convenient. Derived data and queries is actually the same thing as computed values, computed state, and so that's an ability to compute things based on changing state. So we have our flexible shared state thing as an input, and we computed some parts of it based on the principles of how our application works, and so we have computed states. Um, and all optimizations here are also managed, and the components that are subscribed to any kind of computed data or shared state would not unnecessarily render, and would only re-render in case the input values were changed. So that's really suitable. Up-wide observation is a kind of more complicated things to discuss, but I would like to show you what kind of things you can do with that. And so up-wide state observations allows us to do such things as time trail debugging, undo support, so we can manage to have like undo button on our application whenever user does something. And also it is possible to make state snapshots with that. And that could be extremely helpful for both developers and users in some cases. Now I would like to talk to you about motivation. Why did Recoil developers actually thought of creating this library? And what did they wanted to achieve by creating it? So the first, and I believe the one of the great to think about it is that they wanted to have a library for state management without lots and lots of boilerplate code and with a really simple API. And I would say that they succeeded in that, and we'll see that later on our examples. So you'll see that writing Recoil code is really simple, and you don't need lots and lots of things to do that. So I see somebody raised his hand. So let me unmute. Maybe we'll have some question right away. Sorry. Give me a second. Oh, I don't see the raised hand anymore. Yeah, by the way, you can stop me whenever you think something is wrong or you have some really interesting question. That is all right. And for that, you can both use the raise hand feature in the Zoom, or you can also use the Q&A section. And maybe in case I would see the hand raise, I would stop and yeah, and answer your question. So I don't see raised hands. Sorry. Let's continue with the motivation of Recoil JS. Also, the greater thing and the thing that makes Recoil really compatible with, I mean, that makes Recoil outstanding comparing it to its rivals is that it supports concurrent mode of React. And as some of you may know, popular state management solutions like React, Redux, and MobX are not compatible with concurrent mode. At the moment, concurrent mode is of course experimental thing from React, but I believe in future that would get up to speed and be really beneficial to use. And so it would be compatible with Recoil. That's cool. Also with Recoil, developers wanted it to be really easy to split code. And that is technically really easy because we don't have a lot of code to write. And so splitting the code would be really easy. Believe me. Also, developers of Recoil wanted the state to be able to be replaced with derived data without modifying the components that are subscribed and using this piece of state. And well, that's something we would see on an example. And just imagine a component using simple shared state, and it would be able to use some computed data instead, and we would not need to modify the component at all. And the same thing about moving the derived data computation between asynchronous and synchronous state. So the component that will be subscribed to this derived data, to these computed values, would not be needed to be edited in any kind. So it would be able to work both with synchronous and asynchronous data computations. And the rounding up all the things that the developers of Recoil wanted to achieve, the most the thing that is in the policy, I would say, of Recoil is that they wanted to have an improved and extended React state. So they made their own library that is really similar to how things are going in React with state. And maybe one day Recoil could be part of React. We don't know, but that is possible because the overall approach is as Reactish, I would say, as possible. It's really similar. Now, I believe we are ready to move to the core concepts of the library. And what does Recoil do? What developer claim? What does it what it does? So Recoil lets you create a data flow graph that flows from atoms, and that actually our shared states, flexible shared state, through selectors, which are pure functions, and selectors represent computed data, and down into your React components. And let's see what does it mean. So imagine that we have atoms, and atoms are our states. You can think of them as a local state of React components, so use state and some things, but it could be shared all across the React tree. Also, in the core concepts, we have selectors, and selectors, as I have already said, are pure functions that represent derived or computed data. So that's something you could compute based on your atoms, or you can make some async queries and store that in a selector. And on this graphic, we'll also have React component tree. And now let's see how does these core concepts, how do these core elements communicate between each other. So the easiest thing you can do is you can subscribe your React components to an atom. And the cool thing is about flexible and shared state is that the atom could be shared between any amount of components, and those components could be anywhere in the React tree relative to each other. So that's the easiest thing you can do with Recoil. And of course, this state is updatable, and whenever one component, for example, updates the state, all other subscribed components get this update. The other thing you can do, you can pass some data, some information that is stored in your state to a selector. And this selector, as it is a function, it would get these things as an input, do some things, compute some values, I don't know, and then we can subscribe a React component to this selector, and so it would get this some computed values based on your on the things you've done in the selector function, and would get it as and would be able to update whenever this data changes. And the greater thing about Recoil JS is that you can combine all of these basic kind of communication methods between entities. And what am I talking about? It is possible to pass some values from state to a selector and then compute them in some way. And then you can pass this data to yet another selector and, for example, make some asynchronous query to some server, for example, based on the information you've got from previous selector. And after that, you can continue the chain if you need to, and you can pass it to another selector, and respecting some information from another state, you can combine it with the things you've got from your asynchronous call, and pass it to the components down into React tree. And even with such a complicated hierarchy, even with such complicated communication, all of the things would be optimized, and there would were no no were there were no be any kind of unnecessary re-renders of your React components. And that what I found really powerful in terms of that library. And let's now talk about each core concept a little bit in detail. So an atom, as I have already said, is a basic units of states. So you can think of them as of a React component local state. Atoms possess following properties. So they are updatable and subscribable. That means that any component from React tree could subscribe to an atom and update, re-render whenever the state, the atom is being updated. Also, atoms could be created at runtime, which could be really useful, and we'll see that later on our example application. Uh, Also, atoms could be used in place of React local component state, and we'll also see that on an example. And that just means that Recoil approach is really similar to React one, and I'll show you that later on. And if the same atom is used from multiple components, all of those components share their state. And that's just the definition of what flexible shared state is. And you just share the state all across your components, which are subscribed to it. At the bottom left corner of the presentation, you are now able to see the piece of code that represents initialization of an atom. And here you can see that we just call the imported from Recoil library method atom and pass some kind of options to it. And our options are key and default. So key is something that every atom and every selector, we'll see that later on, need, and that's some globally unique key that you need to manage yourself. So that's just the name of your shared state, and you just need to ensure that this string is globally unique all across your application. So there is no other atom or selector with this exact key. And also we can have a default value, which is of course optional. In case your piece of state has a default value, then you can set it. At this case, we are creating a piece of state to hold some font size for anything we can do in the application. So that's something we can do with Recoil. Now I'd like to talk to you about selectors. So selectors are basically pure functions that accepts some information from atoms or other selectors as well as an input. And they compute some values, and then React components could be subscribed to this computed output. Selectors, they have following features. So components can subscribe to selectors just like they can subscribe to atoms. And selectors are basically used to calculate derived data that is based on change in state, and that's what computed data is. So that's computation, calculation of your data or of your dynamic state and how it behaves. Right now, you can see on your screen the piece of code that represents initialization of a selector. And here you can see similar things with an atom. So we call a method selector and pass some options to it. And we also have some globally unique key, this string unique value for all Recoil entities. And it should be globally unique, of course. And the new thing we have is that we have a getter function that should be pure function. And that's where we have this magic of computation of our values. So here we get our things from atoms, from our states, we compute them in some way, and then we return them, and React components are able to subscribe to that changes. And in that particular way, we get, in that particular example, we get the state from the previous slide, our font size state, just concatenate it with the px string. So now we have string that represents the amount of pixels, the human readable string, and then we can return it to our application. So that was a really simple example of how selectors could be used. And of course, this getter function could be asynchronous, and that would not affect the way you write code in any kind. Now let's talk a little bit about installation and caveats about Recoil. So the installation is pretty straightforward. The only and the main dependency of Recoil is Recoil, and you just can install it fully with npm or yarn by typing these commands on the screen. But there are several things you need to take into account when you are thinking about onboarding Recoil on your project. So there is no ES5 support for Recoil, and Recoil is fully developed and implemented in ES6 Plus. So that means that older browsers like Internet Explorer 11 and some older versions of Chrome and Firefox would not be able to run Recoil's code. And so I would like to ask a question. Would we still be able to use Internet Explorer with Recoil? So the answer is kinda. We could transpile our Recoil code with the help of Babel, but the developers would not recommend that because using polyfills and stuff could result in severe performance issues. And so my personal recommendations is not to use Recoil in case your project is about to support older browsers. So that's something you should need to take into account when thinking about Recoil. And now let's have a look on how to write code with Recoil. So at this slide, you can see a pretty straightforward React component, functional component, counter, and it would simply hold a value that would be incremented by 1, starting from 0, uh, every time we click a button. So let's add this button. This button would manage the incrementation stuff. It would call the increment by 1 method that would increment our state, our local component state by 1. And so how would we do that with React only approach? For that, we would use the useState hook, one of the most simple hooks in React hooks. And that would be just simple React local component state. And well, the unfortunate thing about it is that you won't be able to share this piece of state all across your React component tree. You would need to manage some property drilling or stuff, and that is not really um, that's not something you should do, because all of your components would unnecessarily render every time you click this button. And so we need some solution that would uh, allow us to use this piece of state globally, no matter where we are in the component tree. And so we would replace it with another hook, use recoil state, and that's easy. Now we're using recoil. And now this piece of state counter that is passed to use recoil state method could be globally accessible by any kind of a component that is subscribed to it. And the coolest thing is that we don't need to modify our component at all. So now we just can use it. And that is the example I wanted to show you about how recoil is really similar to React. The approach is really easy and similar. And the only thing I would need to explain you is what is this variable counter that is being passed to use recoil state. And that's our atom that we have created before, and it could be code splitted in some other folder in some other file, and you just need to import it and pass to the use recoil state function. It's that easy. And now we came to the part of our tech talk when I would show you the example, some of use case scenarios where recoil shows its power. And our example application would appear like so. So what would we have on it? On the left, we have a list of image components so those are just different clickable images. And on our right, we have metadata component that shows some information about selected image on the left. So it's width, height, and any kind of other metadata information we would need. And of course, all the images are clickable, and on image change, on the selection change, on the click on another image, our metadata component will change. And so in that kind of application, we would need some source of our state that could be shared across the list of images and our metadata component. Let's think if we could do that with React only, without any kind of state management libraries. And you may know that in React, we have a solution for that that is called Context API. With Context API, we can pass and subscribe components to a pieces of state that are um, anywhere in the React tree hierarchy. But there are actually several things we should take into account when thinking about context API in that particular example. So context API doesn't let you to subscribe to a subset of data it contains, and that's what React developer claim. So that's just impossible to do. Also, all consumers that are descendants of a provider will re-render whenever the provider's value prop changes. And summarizing all the things I've said, it simply means that if the value of our provider of context API is an array or an object, which is the case with our list of images, we have like an array of images. Changing this array or object will cause everything subscribed to this provider to be re-rendered, and that's not what we really want. We want just to click on an image and only the metadata component would render, not the whole component tree. But anyway, let's see how could we do that with context API. There is actually a solution for that, and we would need to use not the array of images, but we would need to store every image component, every image data in its own context. And that would look something like that. So for each image component, we would have each provider. And this approach kind of works, but it works until we know the exact amount of elements, the exact amount of image components, and until we are sure that the elements cannot be added dynamically. But why? So in case we'd like to add an element dynamically, what would it be? So we'll try to mount a new provider for that, for a third for a new image component. And as you have noticed, we have mounted a provider to the top of React tree, and we just mutated the whole structure of React tree, and that particular step would cause all of our React tree to re-render. And that, as you may think, is not really optimized, and we don't really want that to happen. So in case the amount of our image components is static, we can do it with context API. But whenever we need to dynamically add new components to it, we should seek for some other approach. And yeah, our other approach would be Recoil, as you may have guessed. And so with Recoil, we would not need all of those providers. We would only need the Recoil root component, and that's just the way you write code with Recoil. That's pretty easy. And let's see what would happen if we would need to add a new image. So imagine that we have atoms that represent the image components, the image data, and for each image we would have a separate atom. And what would be if we would like to add a new image? So we would just add it, and nothing else except of this exact image would re-render. And that's because of the power and optimizations of Recoil. And in that particular case, I believe this situation shows the power of the library and how does it truly shines. And to be honest, we can continue adding more and more elements to our component tree. We can add them as many as we can, and only the new ones would render and would not disturb the existing ones. And well, Recoil developers say that an application that holds up to 10,000 atoms would still work as expected, uh, and no bugs and no performance issues would be seen. So that is really great. I found it like so. And finally, we came to the wrapping up section. And well, in that section, I would like to ask one of the most interesting and important questions of this tech talk. Do we need to use Recoil JS? And you know, my answer would be maybe, because there is one thing I want you to understand. So imagine that you have your React application and it works perfectly fine. You haven't added any kind of new state management libraries or other things to it. And um, so my personal advice is to stick with a native React approach without adding libraries right away. But there could be situation when you can hit certain limitations. And in our example application, we couldn't just do it with the context API. It would be not really performant in the way it's engineered. And when you hit limitations with your React application, in that case, Recoil could be a pretty good fit to order to overcome your limitations. And that way, what I strictly encourage you to do. So you should seek for the tools that would help you to overcome certain limitations. And so let's answer the question, when do we need Recoil JS, and do you personally need to use it in your next project? So we need Recoil when we hit certain limitations. And also when we have not nested state structure, that means that we have like a metadata component in the one piece of our application, then we have some other data on the left, and these components aren't nested. And in that case, Recoil could be pretty good fit. Also, I found Recoil pretty easy to use when it comes to asynchronous queries to do. And so when you need lots of asynchronous stuff to do, and it should be shared all across the React tree, Recoil shines in that situation as well. And also you should try Recoil if you want to try something new, because personally I found Recoil pretty fun, and I've had great time getting acquainted with that. And so I believe in case you have some idea for your pet project or so, you could just try Recoil in it. So you'll see how simple and how beautiful it is. But that's something you should think, of course, yourself. And I hope I've interested you in some way in the topic of Recoil JS, and we'll see if that library would be of any interest to you in future. So on that point, I would like to thank everybody for joining this tech talk, but don't leave, because we have another topic from my colleague Vuk. And so here you can just see a big information about myself and how can we contact in case you want. So you can find me on LinkedIn, and in case you would have any kinds of questions that I won't be able to answer right now, so you are free to contact me. Yeah, and now I will try to answer your questions. I see already a pair of them. Thank you so much for the presentation. Thanks, Maria. Um, Is there anything you can do with Redux but can't do with Recoil? That's a pretty interesting question. And so my answer would be there is nothing you can't do with Recoil that Redux can do. Even if you want to follow similar approach with Recoil, like this thing with dispatching actions and reducers, you still can achieve that with Recoil. And so the developers of Recoil claim this library to be a superset of Redux. So you can do sometimes even more, or not even more, but in more efficient and maybe beautiful way, in the other way, let's say. I hope I've answered your question. I see one more question from Igor. Can you briefly compare Recoil with traditional approaches like Redux and MobX? Of course I can, but I believe my comparison would be pretty straightforward and simple. So the most outstanding thing about Recoil is that it is compatible with concurrent mode, and Recoil and MobX, or MobX and Redux would never, I suppose, not in the nearest future would be compatible with it. And also, from my understanding, the API of Recoil is much more simple than Redux's and MobX's, because you don't have this much of boilerplate code like you do with Redux, and all the uh, the whole library is a little bit simpler than MobX from my on my side. So I hope I've answered your question as well. Uh, so I'll answer like two more questions, I believe, and I'll give my word to the next speaker. I see one more one more question. Is Recoil based on context API? And well, that's something really clever to ask, because uh, the reason why it is compatible with the concurrent mode is because Recoil is based on context API, and under the hood, Recoil is actually some stuff going on, some magic with the native React API, and that is the reason why someday Recoil could be Recoil principles could migrate to React itself, but that's something that is not really considered to be implemented in the future. That's just my thoughts. Oh, we have so many questions. Yeah, okay, the last one. Thanks for your interest. Um, can you answer, please, for what application I would need to use Recoil if I'm pretty new to React? So that is a good question, thanks. Well, I would advise you to use Recoil only in case you are already up to speed with React. So if you have your any kind of application, just do it with React and see if it's working, see if it's doable. And in case you hit limitations, as I've described in the wrapping up section, when you hit limitations, that is the point when you can think about onboarding Recoil. Uh, yep, I hope I've answered this question as well. So thanks, massive thanks for listening to me. It was a great pleasure to talk to you, and thanks for finding time to join for this tech talk. Um, and